There is no article in the National Electrical Code that mandates all wiring within a 480 volts motor starter to be rated for 600 volts solely based on the presence of a 480 volt circuit. The required voltage rating of conductors is determined by the circuit voltage to which they are connected. Therefore, wiring connected to a 24 volts DC coil or contact circuit within the motor starter does not necessarily need to be rated for 600 volts. It is important to understand the specific requirements outlined in the National Electrical Code concerning conductor insulation voltage ratings. Article 310 covers conductors for general wiring. Section 310.7 addresses conductors operated at greater than 600 volts nominal. It specifies requirements for insulation shielding and ampacity adjustment factors. However, this section primarily deals with conductors exceeding 600 volts and doesn't directly dictate the voltage rating for lower voltage control circuits within a 480 volts motor starter. Section 310.10. It clarifies that conductors must be insulated. The insulation is suitable for the voltage, circuit conditions, operating temperature, and location of use. This means that the insulation rating must be adequate for the specific voltage present in that part of the circuit. Now consider the control circuit within the motor starter that operates at 24 volts DC. These conductors only need to be insulated for 24 volts DC plus a safety margin. Using 600 volt rated conductors would certainly be acceptable, as it exceeds the voltage requirements, but it is not explicitly mandated by the NEC if the control circuit operates at 24 volts DC. There are sections that address control circuits. Article 430 covers motors, motor circuits, and controllers. Part VI of Article 430 specifically deals with motor control circuits. Section 430.71 defines a motor control circuit as the circuit controlling the motor, transformer, or other apparatus. It does not carry the main power current. Section 430.72 addresses overcurrent protection of control circuits. This section details the requirements for protecting control circuit conductors from overcurrents. It specifies the maximum overcurrent protection device rating base and the conductor ampacity. It does not mandate a 600 volts insulation rating for conductors and a 24 volts DC control circuit. Section 430.73 discusses the mechanical protection of control circuit conductors. It requires control circuit conductors to be protected from physical damage. This section focuses on the physical protection of the conductors and not on their voltage rating. Section 430.74 covers disconnecting means for control circuits. It requires a disconnecting means to be provided. The disconnecting means must disconnect the control circuit from its power supply. This section deals with the disconnection of the control circuit and does not mandate a 600 volts insulation rating. When selecting conductors for a motor control circuit, one should consider the following factors. Firstly, the voltage rating of the conductor must be equal to or greater than the maximum voltage present in that part of the control circuit. Secondly, the conductor ampacity must be sufficient to carry the maximum current that the control circuit conductors will be exposed to. Thirdly, the conductors must be suitable for the operating temperature and environmental conditions. Fourthly, the conductors must be mechanically protected from physical damage. Fifthly, the conductors should be selected according to applicable industry standards and best practices. To be clear, while the NEC doesn't mandate 600 volts rated wiring for all components within a 480 volts motor starter, it is permissible to use it. In some cases, it can be advantageous to standardize on a single conductor type to simplify inventory and reduce the risk of using the wrong conductor. This practice ensures that all wiring within the enclosure meets or exceeds the necessary voltage rating and can improve the overall safety and reliability of the installation. There are certain instances where specific components within a motor starter might require higher voltage rated conductors. For instance, if a portion of the control circuit is derived directly from the 480 volts supply through a control power transformer, the conductors connecting the transformer primary to the 480 volts supply would need to be rated for at least 600 volts. This is because these conductors are directly connected to the 480-volt source. Also, if the motor starter is installed in a harsh environment with high temperatures or corrosive substances, it may be prudent to use conductors with high temperature or chemical resistance ratings. This will ensure that the conductors can withstand the environmental conditions without degrading or failing. When installing a motor starter, it is crucial to refer to the manufacturer's instructions and specifications. The manufacturer may have specific requirements for conductor types, sizes, and voltage ratings. These requirements should be followed carefully to ensure that the motor starter operates safely and reliably. It is always recommended to consult with a qualified electrical engineer or inspector to ensure that the motor starter installation complies with all applicable codes and standards. They can provide expert guidance and identify any potential hazards or issues. Keep in mind that the NEC is updated regularly, so it is essential to stay up to date with the latest edition. Changes to the NEC can affect the requirements for motor starter installations. Reviewing the relevant sections of the NEC regularly can help ensure compliance. The requirements for conductor voltage ratings can be found in Article 310 of the NEC. Additionally, Article 430, Part VI provides specific guidance on motor control circuits. These articles should be consulted whenever installing or modifying a motor starter. To summarize, the National Electrical Code does not require all wiring within a 480 volts motor starter to be rated for 600 volts. The voltage rating of conductors is determined by the voltage of the circuit to which they are connected. Wiring connected to a 24 volts DC control circuit does not need to be rated for 600 volts unless otherwise required by the manufacturer's instructions or specific environmental conditions. Always follow the NEC and consult with a qualified professional to ensure a safe and compliant installation. In addition to voltage rating, conductor ampacity is another crucial factor to consider. The ampacity of a conductor is its current carrying capacity. It is the maximum amount of current that a conductor can safely carry without exceeding its temperature rating. The NEC provides tables that list the ampacities of different conductor types and sizes based on their installation type and installation method. When selecting conductors for a motor starter, it is essential to choose conductors with sufficient ampacity to carry the maximum current that they will be exposed to. The ampacity of the conductors must be greater than or equal to the motor's full load current, as well as any other loads that the conductors may supply. Overcurrent protection devices, such as fuses or circuit breakers, are used to protect conductors from overloads and short circuits. These devices are designed to trip and interrupt the circuit if the current exceeds a certain level. The NEC specifies the maximum overcurrent protection device rating for different conductor sizes. It is crucial to select overcurrent protection devices that are properly sized for the conductors they are protecting. Undersized overcurrent protection devices may trip unnecessarily, while oversized devices may not provide adequate protection. Grounding is another critical aspect of motor starter installations. Grounding is the process of connecting conductive parts of the electrical system to the earth, providing a low impedance path for fault current to flow back to the source. Grounding helps to protect people from electric shock and to prevent damage to equipment. The NEC requires all motor starters to be properly grounded. Grounding conductors must be sized and installed according to the NEC. Bonding is the process of connecting different conductive parts of the electrical system together, creating an electrically conductive path between them. Bonding helps to equalize the voltage potential between different parts of the system, reducing the risk of electric shock. The NEC requires all motor starters to be properly bonded. Bonding conductors must be sized and installed according to the NEC. Control power transformers are often used in motor starters to provide a lower voltage power supply for control circuits. Control power transformers step down the 480 volts AC supply to a lower voltage, such as 120 volts AC or 24 volts DC. The NEC provides specific requirements for the installation of control power transformers. These requirements include overcurrent protection, grounding, and wiring methods. Motor starter enclosures are designed to protect the components of the motor starter from the environment. Enclosures are typically made of metal or plastic and are available in various NEMA ratings. The NEMA rating indicates the level of protection that the enclosure provides against dust, water, and other environmental factors. When selecting a motor starter enclosure, it is essential to choose an enclosure that is appropriate for the environment in which the motor starter will be installed. If the motor starter is installed in a wet or dusty location, a NEMA 4 or NEMA 4X enclosure may be required. Wiring methods refer to the way in which conductors are installed and supported. The NEC specifies various wiring methods that are permitted for use in different applications. Common wiring methods include conduit, cable tray, and direct burial. When selecting a wiring method for a motor starter, it is essential to choose a wiring method that is appropriate for the environment and the type of conductors being used. Conduit is a rigid or flexible tube that is used to protect conductors from physical damage. Conduit is available in various materials, including metal and plastic. Cable tray is a system of metal or plastic trays that are used to support conductors. Cable tray is often used in industrial applications where there are a large number of conductors. Direct burial is a method of installing conductors directly in the ground. Direct burial is typically used for underground feeders and branch circuits. Motor starter maintenance is essential to ensure the safe and reliable operation of the motor starter. Regular maintenance should include inspecting the components for damage, tightening connections, and testing the overcurrent protection devices. A qualified electrician should perform motor starter maintenance. Troubleshooting motor starters requires a systematic approach. The first step is to identify the problem. The next step is to isolate the cause of the problem. Once the cause of the problem has been identified, it can be repaired. A qualified electrician should troubleshoot motor starters. Lockout/tagout procedures are essential to ensure the safety of workers who are performing maintenance or repair on motor starters. Lockout/tagout procedures require that the motor starter be de-energized and that a lock and tag be placed on the disconnecting means to prevent the motor starter from being accidentally energized. Only authorized personnel should perform lockout/tagout procedures.